The U.S. military's low-cost uncrewed combat attack system, Lucas, a long-range one-way attack drone, is set to receive Shield AI's HIVEMIND autonomous control software. The integration effort was awarded by the Office of the Undersecretary of War for Research and Engineering, OUSW R&E, and is aimed at introducing advanced autonomous teaming, AI-driven coordination, and swarm capabilities into the Lucas platform. Managed by the Office of the Deputy Assistant Secretary of War for Prototyping and Experimentation under OUSW R&E, the Lucas initiative is designed to deliver affordable mass by fielding large quantities of inexpensive strike drones capable of operating in coordinated formations. These systems are intended to overwhelm enemy air defenses through saturation tactics while providing a scalable and cost-effective strike option. Derived from the Iranian Shahed-136 design, each Lucas air vehicle is estimated to cost approximately $35,000, significantly less than most conventional precision-guided munitions that offer comparable range. Viewers may note that Lucas reportedly made its combat debut during the opening phase of Operation Epic Fury, when large numbers of the drones were launched against targets in Iran as part of the campaign's initial strike package. In this video, Defense Updates analyzes how Lucas with HIVEMIND AI is set to enhance U.S. military's drone warfare capacity. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. Developed by SpectreWorks of Arizona, Lucas was conceived as a low-cost yet highly adaptable unmanned strike platform capable of supporting a broad range of operational requirements. The system incorporates a lightweight, low-signature airframe designed to balance speed, maneuverability, and survivability in contested environments. Although detailed specifications have not been publicly disclosed, available information indicates a wingspan of approximately 8 feet, length of 10 feet, and a gross weight 86 kilograms, 190 pounds. In contrast to the Iranian Shahed-136, which relies on the 4-cylinder Mato MD-550 engine, Lucas is powered by a 2-cylinder DA-215 engine. This propulsion system is believed to provide improved fuel efficiency while generating a smaller acoustic signature, enhancing the platform's ability to operate with reduced detectability. The drone is reported to achieve speeds of up to 120 miles per hour, 195 kilometers per hour, and possesses an operational range of roughly 800 kilometers, 500 miles, enabling it to conduct long-range strike missions against targets deep within hostile territory. The airframe is constructed using advanced composite materials and incorporates radar attenuating treatments intended to reduce its radar cross-section. Lucas also offers considerable deployment flexibility through its modular launch architecture, supporting methods such as rocket-assisted takeoff, as well as mobile truck-mounted launch systems. This allows the platform to be rapidly deployed from dispersed locations and adapted to a variety of operational scenarios. One of Lucas's most significant advantages over the single-use Shahed-136 is its flexibility and potential reusability in certain configurations. The system is built around an open architecture framework that enables rapid mission-specific reconfiguration without extensive hardware modifications. Its modular payload bay can accommodate a diverse mix of sensors, electronic warfare equipment, reconnaissance packages, and munitions, allowing operators to tailor the platform for strike, surveillance, decoy, or support missions. Lucas incorporates a satellite communications (SATCOM) terminal, providing connectivity over extended distances. Shield AI, a deep tech company founded in 2015, has positioned itself as a leader in defense autonomy with its HIVEMIND autonomy software program. Launched in the same year, HIVEMIND is an AI-powered ecosystem designed to enable drones and aircraft to operate autonomously particularly in challenging environments such as GPS denied or communication degraded settings. Shield AI, in its statement, describes HiveMind as an AI-powered autonomy software, enabling unmanned systems to conduct complex missions in GPS and comms-denied environments through modular integration, operator confidence, and multi-platform deployment. It can make decisions without real-time human intervention, critical for operations in hostile or contested areas. The architecture is modular and open, making the HiveMind platform agnostic. It supports integration with third-party systems and can be tailored for single or multi-agent operations through recomposable blocks, allowing flexibility across diverse mission sets. Shield AI's HiveMind was also the same AI agent controlling the autonomous X-62A Vista that flew former Secretary of the Air Force Frank Kendall in 2024. Already, HiveMind has been inserted in a variety of other platforms, including aboard Anduril's YFQ-44A under the U.S. Air Force's Collaborative Combat Aircraft (CCA) program, the U.S. Navy BQM-177 test aircraft, the Airbus UH-72B Lakota helicopter, and the Destinus Hornet platform. The company says it has integrated AI pilots for 28 different platforms to date. Under the new initiative, HiveMind will serve as an AI-enabled pilot for Lucas, enabling groups of drones to coordinate their actions, maneuver cooperatively, and respond to evolving battlefield conditions in real time. The integration is intended to transform individual platforms into networked, collaborative systems capable of operating as a cohesive force rather than as isolated assets. Brandon Singh, president and co-founder of Shield AI, described the significance of the effort in a company statement. Lucas is about delivering affordable mass, but mass without coordination is limited in value. HiveMind is the AI pilot that makes that mass intelligent. It's the autonomy layer that enables teams of drones to sense, decide, and act at scale. We're proud to partner with OUSW R&E to put this capability in the hands of the warfighter at the speed of relevance. HiveMind is designed to simplify the management of networked uncrewed systems by enabling a single operator to supervise and direct multiple platforms simultaneously during complex, highly synchronized operations. While human operators retain control over critical decisions, including the authorization of strikes, the autonomy software assumes responsibility for navigation, coordination, task execution, and overall mission management. Operators can intervene at any point, redirect individual drones or the entire formation, and modify mission objectives as operational requirements evolve. For appropriately equipped Lucas platforms, the HiveMind AI pilot provides the ability to perceive the surrounding environment, evaluate available courses of action, and execute missions autonomously without requiring constant human control. Unlike traditional autopilot systems that primarily follow pre-programmed routes, HiveMind is designed to continuously assess changing conditions, adjust mission plans on the fly, avoid threats and obstacles, and carry out sophisticated tasks with minimal operator involvement. Discussing the role of AI in enabling autonomous mission execution and coordinated swarming, including operations in GPS-denied and communications-degraded environments, Seng compared the underlying technology to that used in advanced autonomous vehicles. Seng explained, "We're using a lot of the same technical approaches that Tesla or Waymo are using. We use sensors on board these drones and weapon systems to perceive our environment. We got a GPU that thinks about what to do and is programmed to think about the different missions that it's executing in said environment, and then we take action, maneuvering the drone or the weapon system in the environment." Although baseline Lucas drones have already demonstrated notable operational effectiveness during the recent conflict with Iran, Pentagon officials and industry partners believe the platform's true potential will emerge once advanced autonomy is integrated. Shield AI argues that pairing Lucas with the HiveMind AI pilot could substantially improve combat performance by increasing target engagement effectiveness, reducing the cost required to achieve operational effects, and enhancing overall mission success rates. The addition of an AI pilot represents a major step forward for the program. For decades, military planners have envisioned swarms of autonomous systems capable of operating as coordinated teams rather than simply large numbers of independent drones launched simultaneously. HiveMind is intended to bridge that gap by enabling genuine collaborative behavior among multiple platforms, allowing them to function as an integrated combat network rather than a collection of individual assets. With AI-enabled autonomy, Lucas drones will be able to distribute tasks among themselves, coordinate attack profiles, and maneuver cooperatively to achieve mission objectives. Perhaps more importantly, AI-enabled swarms offer a degree of resilience that conventional drone formations cannot easily match. If individual drones are lost to enemy action or mechanical failures, the remaining members of the swarm can automatically redistribute responsibilities and continue the mission with minimal degradation in performance. Because Lucas supports a modular architecture, different drones within a formation can carry specialized payloads, including sensors, electronic warfare systems, decoys, or strike munitions, while the AI continuously optimizes how those assets are employed to maximize the effectiveness of the group as a whole. With flight trials of HiveMind-equipped Lucas drones expected to begin within the coming months, the program is approaching a critical milestone. The ultimate question, however, is whether these advanced capabilities can be fielded without undermining the affordability that lies at the heart of the Lucas concept. The prospect of combining affordability, scalability, and advanced autonomy into a single platform is what makes the evolution of Lucas particularly interesting.